Okay, so I will start. So good afternoon to everybody. My name is Davide from Polytechnic di Milano. We'll be presenting FARGO, a fair context-aware group recommender system. So we go from recommender systems to group recommender systems because there are a lot of activities like watching a movie, going to a restaurant, or going to vacation, which are intrinsically group-based. And to recommend such activities to groups, traditional single-user recommendation techniques cannot be adopted. And as a consequence, over the years, a number of group recommender systems have been developed. And the group recommendation problem introduces further challenges with respect to the single-user recommendation problem. In fact, the group members may have different preferences, and it may not be possible to find a recommendation that meets the tastes of everyone. The groups may be formed by people who happen to be together for the first time. And in this case, the only thing that you can do is basically use the single individual preferences and to aggregate them by means of some aggregation function. And third, when in group, people may exhibit different behaviors. And there are some users that may be more submissive, and while there may be some other users that may be more bossy or overpower the others. Another thing that is very dear to us is context awareness. In fact, recent studies have shown that context awareness in group recommender systems can generate a very high increase in performance. But the guiding principles of this work is for sure fairness. In fact, recommending to groups items to be enjoyed together poses many ethical challenges. And as a system whose unique objective is to achieve the best possible recommendation performance, might learn to disadvantage submissive users in favor to more aggressive ones. In this work, we extend the previous work from our group, which is called CTX-INFL, which is a group recommender system for ephemeral groups, which is based on the concept of influence, and it is also context aware. In CTX-INF, the group preference for an item is obtained by aggregating the individual preferences of the group members on the basis of their influence. So in each context C, where a context is a conjunction of a set of dimension and value pairs, the influence of a given user U is derived offline by comparing the behavior of U when alone with use behavior when in groups. And basically the influence tells how many times a group containing U have selected one of your favorite items. So we can say that the value of the influence for a given user in a given context, because it is very important that this influence should be context aware, quantify the ability of the user of the user U to direct the group's decision towards his or her own tastes while in that context. And then the top K recommendation for a group are computed online. And when a group of users requires the system to suggest a recommendation for items to be enjoyed together, the system computes the group preferences for all the items that are available at the time instant, and then returns the K items with the highest score. So given a group, its preference score for an item E in context C is computed as the average of the preferences of its members, weighted on the basis of each member influence. And now that we have seen how CTX-INF works, it's easy to understand that being CTX-INF based on the concept of influence, it inevitably privileges the preferences of the most influential users, which is basically the contrary of fairness. And so what we want to do is to add a fairness element so that the recommendation process is not the preferences of one or few users, which can be considered leaders or using a more contemporary word, influencers. So our aim for FARGO is to maintain CTX-INF general structure, which already proved to be effective in giving recommendations, mainly due to the context awareness, and it is also scalable, and we want to save this. And what we want to do is to propose fairness adjustment to add to CTX-INFL. Following this intuition, we propose to add a fairness factor to the computation of the group score for each item. And in order to modify the top K list so that items which would represent fair recommendations will not appear on top. In order to keep it scalable, we decide to add our fairness element online. So we just want to re-rank the group scores for items available at that time for that specific groups in order to make it more fair. So here you can see CTX-INFL group score, to which we add a multiplicative term, which we call consensus. And consensus quantifies how much the individual preferences of the group members agrees on the evaluation for an item. In order to maintain the computation of the group score for each available item scalable and lightweight, we decide to build our fairness element just using the individual contextual scores, which are already required by CTX-INFL to compute the score. So we do not need any more information to compute our fairness element. And basically, the consensus of a group G on an item E in a context C is defined as 1 minus the variance of the group member scores for item I, in context C. And so that the consensus for an item for which the users gave a similar evaluation will be close to 1. So we multiply by 1 and we basically keep the old CTX score, while it will reach its minimum if the scores, the individual scores for a given item among the user members is very different. We exponentiate consensus to the group size according to the intuition that the magnitude of the problem of unfairness in group recommendations is proportional to the group size. In fact, the bigger the group is, the bigger is the potential harm produced by recommending solely taking into consideration the leaders or influencers. As an example, let's take a context which is daytime, a group of 2 users, C1 and Q2, an item E which is available at time of recommending, and let's say that the influence of U1 in C is 1, while the influence of U2 in C is 0.3. And let's see that we have two scenarios. The first one is the scenario in which U1 and U2 have very different scores for item E in context C. And the second one is when they have similar scores. And as you can see, score given by CTX-INFL, which is the one on the second row, is the same in both cases. And we do not want this because the first case is very unfair, while the second one is not a problem. And as you can see, we can change fair score. And in the second case, the one in which the 2 users agree, the impact of consensus is very minimal. And so the blue score, the FARGO score, is very similar to CTX-INFL score, while in the other case is much lower, so that we can achieve some. We test our systems on 2 real datasets. First one contains viewing information related to almost 8 users, 21,000 distinct programs broadcasted over there and by satellite in Italy. The log spans from December 2000 March and contains almost 5 billion entries, among which we retain just the ones longer for 3 minutes. We have 3.5 million of viewings, which are done by individual users, which we use to compute the individual scores, while the remaining 1.5 million, more or less, have been done by more than one person. We have 2 context dimensions, which are day of the week, which is either weekday or weekend, and the time slot, which is which are 8 different time slots across the day, basically, so that we have a total of 16 context combinations. While the second dataset has been created specifically for this work by asking our students and their friends to fill in 2 different forms. The first one is a form which collects content individual preferences, while the second one is a group form which is to be filled in groups, asking for a collective choice of a music artist in a particular context. We consider 2 listening contexts, which are during a car trip and at dinner as background music, which have been chosen since they are common situations users can relate to, both when alone and when in group, and also considering that users probably have different preferences in the 2 contexts, so that the context awareness is enhanced. And we have as items 30 music artists well known in Italy across different genres, and we have 208 users and 498 context-aware group listenings, of which 272 are of 2 users, 158 of 3 users, 32 of 4 users, and 36 of 5 users. Sorry. We evaluate our system using recall@k for the recommendation performance, while for the fairness, we use 2 measures. For the first one is the score disparity, was proposed in a paper of 2018, if I remember well, and is computed at the user as the Gini coefficient of the user satisfaction, where the user satisfaction is the relative gain achieved by a user due to the actual recommendation with respect to the optimal recommendation strategy. The second one is called recommendation disparity and is computed as the Gini coefficient of user gains, which means how many of the recommended items match the user's top K. Sorry, can I ask how much time is left so that I know how to go deep on the results?
No. Go. So 5 minutes left. 4 minutes left.
Okay. We compare our approach against 7 other group recommender systems, which are either baselines, but they are baselines that, despite not being developed to explicitly address ethical issues, aggregate individual preferences in a way that resembles fairness, or they are group recommender systems specifically developed to be fair. We have average, which maximizes the average of a group member's scores for an item. We have fairly, which formulates the problem of fair group recommendations as a fairness. And after proving that this optimization EPR propose a greedy formulation to achieve it, which is Pareto efficient. Sorry, it's not greedy, it's Pareto efficient. We have fair prop and heavy free, which are proposed by the same authors. And fair prop is fair mass proportionality, which is when a user is satisfied, which says that a user is satisfied by an item I, if I is ranked in the top rated items for you, while heavy freeness is when the rating for a user for an item is among the top ratings of the users in the group for E. So you're not envious of the others which receive a better recommendation, basically. And also in this case, both formulations are NPR, so the authors the approximation. This is a very famous paper which computes the group score for an item by means of a linear combination of 2 components. The first one is relevance, which is the utility based, so a good. And one is disagreement, which is the member that accounts for fairness. We have which is very well known, which maximizes the low score above all members. And then we have GFAR, which is a very recent method that provides a greedy algorithm to achieve what they call rank sensitive balance, which is when in an ordered set of recommended items group, the relevance of the items in the top n is balanced across different values of n. So if you take the top n is balanced, the top 2 is balanced, and so on. And these are our results. As you can see, FARGO always delivers the best recall, probably due to being the only one context-aware algorithm. While for what regards the fairness measure, so the score disparity and the recommendation disparity, it's not easy to find the best overall method. In fact, it is not possible. In fact, except for this, for the disagreement-based algorithm, there is at least a value of k in at least one of the two datasets in which every other method is the best. And so our takeaway on this is that balancing together fairness and recommendation performance is a trade-off, and it's not a simple one. We believe that FARGO is a good answer to this trade-off. In fact, it consistently delivers the best recall while being firm on par with others. But what we want to stress is that it's despite all the formulation of fairness among the 8 attributes are all plausible and all make sense from an intuitive perspective, there is not a best one, and values across all the two is a varying problem, which certainly deserves more research, and yeah, we plan to go on in investing in this topic. So thank you for listening. If you have questions.